Hey guys, how's it going? I thought I'd give you how to do these problems. Let's go over them kind of quickly here so you guys are all set for your test next class. Um, First off, the first two should be pretty easy on how to graph, right? This is just going to be a parabola. Okay, that's going to go through 3 and 5. Let me go over these ones relatively quickly. Okay, now the next one, this is going to be an upside down parabola. That's going to go through 2 and -5. Okay, and then they get to be a little bit harder after that. But so this is going to be to the third degree. It's going to go through -3, 3, and -5. Okay, this is degree 3, leading coefficient's positive, so it's going to come down like that and like that. And then they start to get a little bit harder. All right, number 4. So this is of degree, let's see, 4, 5. The leading coefficient is negative, so the end behavior is going to look like this. Okay, so I'm going to have a 0 at 0, 1 at 4, and 1 at -2. Okay, I'm going to, at -2, it's going to flatten out, down through, like so. Number 5 is a little bit trickier because you have to factor it. First off, they have an x in common, so it'll look like that when you factor that out, and then this factors nicely into x plus 4, x plus 2. Now this is going to be of degree 3 and positive, so it's going to look similar to that graph right there. But I'm going to have a 0 at 0, 1 at -2, and 1 at 4. Look like that. All right, now using some of these graphs, so on your test, you could do it either way. I don't really care. You can either use sign analysis or by graphing. But I'll do them both ways for you. So on number 6, that's the same upside down parabola from the one up above, where I'm going through at 2 and -5, and I'm looking for where this thing is bigger than 0. So I'm looking for where it's above, right, because it's bigger than 0. So that is from here to here. That's the part that's up above, right here. So my answer is going to be when x is in between -5 and 2. Okay, now let's say you want to do this sign analysis wise. So you would put, and the reason that this parabola is upside down is because of that negative sign. So I'm going to put a dot on -5 and one on 2. And then you are going to pick points that aren't those points, like let's say 0, 10, and -10. And if I picked a -10, you got to be careful of this negative sign out front, okay? Because I have that negative sign, it's going to be there. And then inside of this parenthesis is going to be -12, and that's going to be -5. We don't care about the actual numbers, we just care about the signs. You have an odd number of negatives, which means it's negative. Now let's say I plugged in a 0. I still have that negative sign out front, but then I'm going to have a -2 and a +5. Negative times a negative is a positive. And if I have a 10 out here, I have my negative, and I have a positive and a positive inside of my parentheses, which is going to be negative. So you're looking for when it's bigger than 0, so you're looking for the 10, which is right there. So it's still the same answer. Okay, next one. So I'm going to do it graphically first, right? But this is going to be, you're looking for where it's above the x-axis. This is of degree 3, and the leading coefficient's positive, so it's going to look like that. The end behavior is going to be like that. I'm going to have a 0 at -8, I'm going to have one at 2, have one at 5. Okay, so it's going to look like this, coming up through. I'm looking for where it's less than 0, and it's less than 0 right here and here. So my answer is going to be when x is less than or equal to -8, or when it is in between 2 and 5. Okay, and if you did that one sign analysis wise, it's going to be very, very similar to that, where it's going to be, you pick points that aren't those points, like -10 is going to be negative, positive, negative, positive, and you look for where it's positive. Number 8, I'm going to do this one just by graphing for right now. Okay, so I have -2 and I have 4. Okay, so this is a triple root, which means it's going to go right through. That's a double root, which means it's going to bounce off. So I have my triple root and I have my double root. So it'll look like that. So parts where it's bigger than or equal to 0 is going to be when x is bigger than or equal to -2, right? Everywhere where it's above, which happens to be like right here. All right, number 9. Okay, now you should definitely do this one with sign analysis. We're going to put all these numbers in here, so it's going to be the opposite, right? So instead of +2, it's -2. You got 4, and then you got 5. And you're going to pick points that aren't these points in between there. So let's go with like -10. Let's go with 0. Let's go with 4.5. Let's go with 10. Okay, now when you're plugging these in, same things for multiplications. If you have an even number of negatives, then it's going to be positive. So if I plugged in a -10 there, I'm going to have -8. We have -15 squared, so you get 2 negative signs, and then negative on the bottom. So 4 negatives make a positive. Okay, let's say I plugged in a 0, I'm going to get plus, minus, minus, over, minus. So I got 3 of them, so that's going to be negative. Now let's say I got 4.5. I'm going to have positive, negative, negative, over a positive. So 2 negatives together become a positive. And if I have 10s, if I plugged in a 10, I'm going to have positive, 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 over positive, which is positive. So I'm looking for where this thing is bigger than 0. So I'm looking for all of my positives. So here, here, and here. So this part is going to be when x is less than -2, and then I'm looking for in between 4 and 5. And I'm looking for when it's bigger than 5. Okay, it's not equal to, it's equal to 0 at 5, it's not bigger than. So I can't just say when x, I can't do it like I did on problem before, because it's not and equal to. All right, now I would say that these ones are probably going to be the hardest ones that are going to be on the test, but very doable. I'm going to do these ones all by graphing, and I'm going to do them all for greater than 0. Okay, so for greater than 0, okay, so if you were to graph it, it has to be above the x-axis for these certain conditions. So when x is less than, so in those certain conditions, it has to be above the x-axis. So let's say when x is less than negative, I have to be above. When I'm in between -1 and 3, I have to be above. And when I'm bigger than 5, I need to be above. Okay, so it doesn't really matter what happens down here. I'm just going to connect them down. But this would be an example of something that satisfies all of these conditions. Now to come up with the equation for this, okay, so we have my end behavior that's up and up. So that means it's an even power, and its leading coefficient is going to be positive. So my inequality, I'm going to have x plus 4, x plus 1, x minus 3, x minus 5, and this is all going to be bigger than or equal to 0. Just bigger than. Right, because that's where it's above. Okay, number 11. Same thing, going to be in between 1 and 6. Okay, so that's going to be above. Okay, and I can just kind of continue this as like a parabola. Now, this parabola is upside down, so you have to have a negative sign out front. And that's going to be bigger than 0. Okay, so for this one, okay, so I want to be above the axis when I'm bigger than 2 and when I'm less than 6. So I want to be above the axis like that. Okay, so now this one's just going to be like a normal parabola. So I don't need to put a negative sign out front. And my equation is going to be the opposite of them. It's going to be bigger than 0. Okay, 13 is going to be a little bit on the challenging side. Okay, but you need to be, again, I'm going to do greater than 0. So in between 3 and 5, I want to be above the x-axis. And in between 0 and -1, I want to be above the x-axis. So you kind of have like these two things right there. So I'm just going to kind of connect this down like that. Okay, so just like the parabola, this one's facing down. So when you come up with your inequality, it has to be negative. Just because I chose those. Okay, so I have x plus 1. I have my x. Typically, you throw that out front. All right, that's x minus 0. I have my x minus 3, and I have my x minus 5. And that's going to be bigger than 0. Okay, next one. So to graph this, okay, this is a positive cubic, so it's going to go through at -2 and at 4. I'm going to bounce off right here. I'm going to go through. Now on this one, you have to shade, okay, and it's greater than, so you're going to shade up. Okay, I messed up. This line should be dotted. Sorry. My bad. All right, so that's going to be a dotted line going up. All right. So describe in words why the end behavior. So in this one here, you have to say, talk about it being degree 3 and positive leading coefficient. And talk about what happens as x goes to infinity. So as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. Convince me an ordered pair is actually a solution. So what you should do there is you should actually plug in a point into the inequality. So plug in a point 0, 0, something that gets shaded, and then maybe plug in a point that doesn't get shaded, and just kind of prove that that's going to be that. Okay, multiplicity on this one. So on this one we had x equals negative, x equals -2. We have multiplicity of 2. Okay, so it's a double root, and it's going to bounce off. Okay, at x equals 4, okay, it's a single root, multiplicity of 1, and it goes straight through. The one that we had for warm up the other day was a triple root where it went through, but it flattened out a little bit. All right, the last problem. So you got to come up with the equations of these two lines. Okay, so for the two equations of the lines, oops, sorry. Okay, so you have y equals mx plus b. What's writing? For some reason I can't write now. Pen's not writing. It's weird. For some reason my pen is. All right, so I got cut off.